Microplastics are now an unavoidable part of our environment, infiltrating the air we breathe, the water we drink, and the food we eat. These tiny plastic particles, often invisible to the naked eye, have become a constant companion in our daily lives. For years, their presence went largely unnoticed, but recent scientific research is shedding light on the potential risks they pose to human health. Studies have detected microplastics in human blood, organs, and even in the placentas of unborn babies, raising concerns about their long-term effects. Researchers are beginning to link this widespread contamination to a range of health issues, from hormonal disruption to increased risk of chronic diseases. As our understanding grows, it's becoming clear that microplastics represent a hidden threat, prompting urgent questions about how they might be affecting our bodies and well-being. Recent scientific investigations have uncovered the widespread presence of microplastics throughout the human body, with particles detected in organs ranging from the brain to the liver and even the placenta. These findings are deeply concerning, as mounting evidence now links microplastic exposure to a variety of serious health risks. Studies have shown that higher concentrations of microplastics are associated with increased rates of chronic diseases such as heart disease, stroke, and diabetes. Additionally, certain plastic additives are known to disrupt hormone function, potentially leading to reproductive and developmental issues. Researchers have also found microplastics embedded in arterial plaque, raising the risk of cardiovascular events. The emerging science suggests that these tiny particles may be contributing to a hidden health crisis, underscoring the urgent need for further investigation and preventive measures. Microplastics have demonstrated a troubling ability to infiltrate the brain, breaching the blood-brain barrier once thought to be an impenetrable shield. Recent studies have detected these tiny plastic particles deep within human brain tissue, with concentrations rising significantly over the past decade. Scientists are increasingly concerned about the potential health impacts, as microplastics in the brain may trigger chronic inflammation. This inflammatory response is a known contributor to cognitive decline and neurodegenerative diseases, including dementia. Preliminary research has even found higher levels of microplastics in the brains of individuals with dementia compared to those without. While the exact mechanisms are still being investigated, the evidence suggests that microplastics could play a role in disrupting normal brain function, raising important questions about long-term neurological health. Recent medical studies have revealed a troubling connection between microplastics found in arterial plaque and a heightened risk of serious cardiovascular events. Research published in 2024 demonstrated that patients with detectable microplastics in their carotid arteries were twice as likely to experience a heart attack or stroke within 3 years, compared to those without these particles. Scientists believe that microplastics may trigger inflammation and instability within arterial walls, contributing to blockages and increasing the likelihood of life-threatening incidents. Additional studies have shown that people living in areas with high microplastic pollution face elevated rates of coronary artery disease and stroke. These findings suggest that microplastic exposure is emerging as a significant and measurable risk factor for heart health. As evidence continues to mount, the presence of microplastics in our cardiovascular system is becoming a pressing concern for public health. Microplastics have been detected in some of the most sensitive parts of the human body, including placentas, breast milk, and semen. Their presence in these tissues raises serious concerns about reproductive health and the potential for long-term effects. Studies have found microplastics in every testicle sample examined, with higher concentrations linked to lower sperm counts in animal research. For women, these particles can cross the placenta, exposing developing fetuses to unknown risks and possibly contributing to inflammation and hormonal disruption. The detection of microplastics in breast milk suggests that infants may be exposed from their earliest days of life. While scientists are still investigating the full extent of these impacts, the evidence points toward a troubling link between microplastic exposure and reduced fertility, as well as possible developmental challenges for unborn children. Microplastics may play a troubling role in increasing cancer risk through several biological pathways. Laboratory studies have shown that these tiny particles can cause direct DNA damage in cells, a fundamental trigger for cancer development. Additionally, microplastics are known to provoke chronic inflammation, which creates an environment where abnormal cell growth can thrive. Many plastics contain chemical additives such as BPA and phthalates, which are recognized as endocrine disruptors and have been linked to higher cancer rates in experimental studies. Microplastics also act as carriers, delivering these and other carcinogenic chemicals deep into human tissues. This combination of physical stress, chemical exposure, and persistent inflammation raises serious concerns about the long-term impact of microplastics on cancer risk. While more research is needed to fully understand these links in humans, the emerging evidence highlights a significant potential threat to public health. Microplastics pose a significant threat to the body's immune system. When these tiny particles enter our bodies, the immune system recognizes them as foreign invaders and mounts a response. However, because exposure is constant, this can lead to chronic inflammation, leaving the immune system in a state of perpetual alert. Studies have shown that microplastics can disrupt the normal function of key immune cells, such as macrophages, which are responsible for clearing out pathogens and debris. This disruption weakens the body's ability to fight infections and may even contribute to the development of autoimmune disorders, where the immune system mistakenly attacks healthy tissue. Additionally, microplastics can act as carriers for bacteria and viruses, further increasing vulnerability to illness. The cumulative effect is a compromised defense system, making it harder for the body to maintain overall health. Microplastics can accelerate cellular aging by triggering oxidative stress within our bodies. When these tiny particles enter our cells, they disrupt the function of mitochondria, which are responsible for producing the energy our cells need to operate. This disruption leads to the overproduction of reactive oxygen species, unstable molecules that can damage DNA, proteins, and cell membranes. Over time, this constant cellular stress can cause premature aging and increase the risk of age-related diseases. The process undermines the body's ability to repair itself, making tissues more vulnerable to chronic conditions. Scientists are increasingly concerned that ongoing exposure to microplastics may be silently driving the aging process from within, highlighting the importance of understanding and minimizing our contact with these particles. Chronic body-wide inflammation is a hidden consequence of persistent microplastic exposure. When these tiny particles lodge in our tissues, the immune system responds by sending out a constant stream of inflammatory signals. Unlike the short-term inflammation that helps us heal from injuries, this ongoing response can become harmful over time. Research shows that chronic inflammation is a key driver behind many major diseases, including heart disease, diabetes, arthritis, and even certain cancers. Microplastics act as a persistent, non-degradable threat, ensuring that the inflammatory process never truly subsides. This constant state of alert can exhaust the body's defenses and contribute to the development and progression of multiple health conditions. Understanding this link highlights the importance of addressing microplastic pollution to protect long-term health. Microplastics pose an additional threat by acting as carriers for other toxic substances. Their surfaces can absorb and concentrate pollutants like heavy metals, pesticides, and persistent organic chemicals from the environment. When these contaminated particles enter the body, they can deliver a potent mix of toxins deep into organs and tissues. This process amplifies the harmful effects, as the body is exposed not only to the plastic itself, but also to the hazardous chemicals hitching a ride. Research suggests that microplastics can bypass some of the body's natural defenses, allowing these toxins to accumulate and potentially disrupt normal biological functions. The combined impact of plastic particles and their toxic cargo raises significant concerns for long-term health. Microplastics pose a significant threat to hormonal balance, largely due to the endocrine-disrupting chemicals they contain or attract. Substances like BPA and phthalates, commonly found in plastics, can mimic or block natural hormones such as estrogen and testosterone. This interference disrupts the body's finely tuned endocrine system, leading to a cascade of health issues. Research has linked these disruptions to reproductive problems, including infertility and abnormal development in children. Additionally, hormonal imbalance caused by microplastics can contribute to metabolic disorders, such as obesity and diabetes. The presence of these chemicals in everyday environments means that exposure is widespread, making their impact on human health a growing concern. Understanding this connection highlights the importance of minimizing contact with plastics to protect hormonal health. Reducing your exposure to microplastics starts with a few practical changes in your daily routine. Swap out plastic water bottles for reusable options made of stainless steel or glass. As studies show that even opening a plastic bottle can release thousands of microplastic particles. In the kitchen, avoid microwaving food in plastic containers and choose glass or ceramic for storing leftovers, since heat accelerates plastic breakdown and contamination. When it comes to clothing, opt for natural fibers like cotton, wool, or linen instead of synthetics such as polyester and nylon, which shed microplastic fibers during washing. Installing a high-quality HEPA filter in your home can help capture airborne plastic particles, while a water filter, especially one using reverse osmosis, can remove most microplastics from your tap water. These simple adjustments, when practiced consistently, can significantly decrease your daily intake of microplastics and help protect your long-term health. The evidence is clear. Microplastics pose a growing threat to our health, affecting everything from our brains to our hearts and immune systems. While the scale of the problem can feel overwhelming, informed choices can make a significant difference. By understanding the risks and taking practical steps to reduce exposure, individuals can help protect themselves and their families. Community action also plays a vital role, as collective efforts to reduce plastic pollution can lead to broader changes in public health and environmental safety. Sharing knowledge and supporting one another empowers us to face this challenge together. Ultimately, addressing the issue of microplastics requires both personal responsibility and a united commitment to healthier habits and a cleaner environment. What do you think? Please give us your suggestions in the comments section and subscribe to be informed whenever we upload videos.